All right, on to example 3 from the lesson 3.1. And the purpose of this example is to show you how to graph the graph of the derivative when you're given the graph of the original function f. And what you have on the left side right here, left hand side, figure A is the original graph f of x. On the right hand side, you have the graph of the derivative, but for now, I want you to ignore that. Okay, don't worry about that right now. So right now, we're just going to be concerned with the graph of the original function. And then using this, can we sketch the graph of the derivative, or the f prime of x? So essentially what you're doing is you're trying to graph something that represents the slope of the f of x, okay, at all these points, okay? Namely 1, 2, 3, 4, 5, 6, namely these 6 points. I could even add another point to make it, let's see, 1, 2, 3, 4, 5, 6, 7, those 7 points. What is your slope? And based on those slopes, can we sketch a curve that represents f prime of x? It might not be most accurate, but give us an idea. Okay, so unfortunately, it gives us the slope values at those points. So what I would recommend for you to do is to organize a table of the x and y values. So x represents, again, obviously your x values. F of x just refers to your y values at that point. Okay, but again, as I think about this, okay, we don't need the y values to graph the graph of the derivative. What we need, however, is the values for the f prime of x, or the slope of the tangent line at those x values. So f prime of 0, for example, so this would represent, this right here would represent f prime of 0. What does that mean? It has to do with the slope of the tangent line at x equals 0. So go back to the original function. When x equals 0, over here, when x equals 0, take a look at the point on the graph, take a look at the potential tangent line, and then think about what the slope is. Fortunately, the slope is given to us right there. Okay, so when x equals 0, our slope appears to be 4. So I could write that out. So f prime of 0 is equal to 4 because the slope of the tangent is 4 at x equals 0 for the original function. 1.2, let's go back to the original function. Let's take a look at 1.2. That appears to be point B. When x is 1.2, your slope of the tangent line appears to be 1. So I'm going to write 1 at x equals 1.2. I'm only using 1.2. I know 1.2 seems like a random x value. I'm only using that because that is what's given to me in the graph. Can you use other points in the graph that's not given to you? Absolutely. You could use other points to estimate the slope. For example, when x equals 1, you could try to estimate the slope for that. You could use 1.5, you could use 2.5, okay, but for now I'm going to be using what's given to me. When x equals 2, that appears to be point C on the graph, your slope is 0. Repeating this process, when x equals 3, your slope is negative 1, so that means f prime of 3 is negative 1. When x equals 5, your slope is negative 1 again. So not much has changed in between x equals 3 and x equals 5. Okay, slight changes you could see in the slope, but nothing much, nothing drastic in between x equals 3 and x equals 5. When x equals 6, your slope is 0 again because of that little plateau. Okay, if we zoom that in, okay, you could see that the slope changes from negative to positive in a smooth transitional pattern. Okay, same thing happened here. You have a horizontal tangent. Okay. And when x equals 7, it's not given to us, but using symmetry, using the fact that the slope appears to be, at 7 appears to mirror the slope at x equals 5, so you could say that that slope is positive 1. So now based on this information, so now you have the values of f prime of x at those 7 x values, then you could plot those points. And then when you plot those points, you'll get something like this. You'll get the answer. Okay, so that right there is an idea, a method for you to sketch the graph of the derivative using the slope at these individual points of the original function.